Alright, this is day 1 of graphing simple radical equations. We're going to do level 1 in this video. And in this video it says use your knowledge from transformations in semester 1 to find at least 3 exact points and then sketch a graph. So here's the graph that we're given. This is a radical function. It's saying we're going to take the square root of some number and then when we add 5 to it. So remember back in semester 1, transformations, when you had a value that was included inside of parentheses, that told you to shift the graph left or right. So radicals are similar to parentheses in that they group things together. So in this case, this is grouping these together. So it's telling me that I should be adding 5 to my x value. Remember, when it was inside of the parentheses or grouped together, we did the opposite operation when we graphed it. So what this looked like when we graphed it was I really should be shifting 5 to the left. So I can create a table of my x and y values, and I can use those to help me graph my function. Very quickly though, let's take a look at what a graph of a radical equation looks like. So if you look at your calculators, if you hit y equals, the parent function of this graph or this function is y equals x squared. So all I have to do is do second x squared to get the square root function and then type in x. When I graph this, I'm going to get a sense of what my graph should look like. It's different than what we've seen before, so I want to make sure that we're aware of what these graphs look like. Let's take a look at what happens with this graph. I know when I shift 5 to the left, that's going to give me 0 as my output. So I know if I go negative 5 in for x, 0 comes out. That's the vertex or the point where we know that we can shift our graph to. Since we're dealing with a square root, I want to plug in numbers for x that are going to give me nice numbers that I can graph on my graph. So since I'm square rooting, I want to square root numbers that are perfect squares. So remember, the perfect squares are 1, 4, 9, 16, 25, and then so on. Because this is 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. So now that I have 1 point, we need at least 3 points to graph our line. I can plot negative 5, 0. 1, 2, 3, 4, 5. I want to plug in values of x that are going to give me one of these numbers. So I know right away if I plug in negative 1 plus 5 is 4, and the square root of 4 is 2. So I can plug in negative 1, 2. Alright, another number I know will work is if I plug in positive 4, because positive 4 plus 5 is 9. So if I do the square root of 4 plus 5, I get 9, and the square root of 9 is 3. And that gives me a good sense of where my graph is going in terms of its direction. Now that you have 3 points, you can connect them, and then now you've got your graph of your radical function. So again, when you're graphing these ones for radicals, you want to try to use values of x that are going to help you get a perfect square to make it easier to square root. So try the following on your own and see if you can get those graphs.